next lesson is on understanding chemical formulas. So we've already tried looking at some chemical formulas in class. We built some molecules using chemical formulas. So what we're going to do today is go through some more of the rules for chemical formulas, what the numbers and these symbols actually mean. So before we get started, this isn't in your notes, but what do you think of when you see the following symbols? So a lot of people think for the first picture, they think hockey, they think Wayne Gretzky, they think like scoring lots of goals, setting records, things like that. For the second, people will think fries or Big Mac, McDonald's. So what ends up happening is we use the same thing in chemistry. We have certain symbols that represent certain things, and depending on the combination of those symbols and numbers, it actually will mean something very specific. So let's do a quick review so you guys can fill in these blanks as we go. So a compound is a pure substance made up of two or more elements chemically bonded together. That's what we're going to look at in more detail. The properties of a compound are very, oops, sorry, where did it go? Different, there we go, from the properties of the individual elements that make it up. So an example that I like to use is salt, sodium chloride. So the formula for sodium chloride is Na for sodium and Cl for chlorine. And that's table salt, or what you put on your French fries. It's a harmless white solid, but if we separate it, sodium is a silvery solid that's highly corrosive and reacts really violently with water. And chlorine is a green poisonous gas. So when you have these two elements separate, they're very toxic and they're really not good for you. But when you combine them together, suddenly they become something completely edible, which is really interesting. So remember that compounds are made up of elements, but don't necessarily have the same properties that these elements have. So make sure you have all those blanks written down, and we'll go on to the next slide. So remember, each element is represented by a chemical symbol that consists of either a single letter that is always capitalized or two letters and only the first is capitalized. I'll give you a second to copy those down and then we'll go through some examples. So some examples, I'll write some here up on the board. Carbon. The symbol for carbon is a capital C. And when we look at, say, something like calcium, the symbol for calcium is a capital C and a lowercase a. So we've sort of looked at those many, many times before. You can copy those two examples down in your notes if you'd like. All right, so now we're going to look at how to interpret and understand a chemical formula. All chemical compounds can be represented by a chemical formula. A chemical formula uses symbols and numbers to represent the compound's composition. So the example I gave you is H2O. Now this is a really easy one. It's very common. You guys all know that it's water. What does it actually mean to say H2O? Well, it means, first off, this 2, it's called a subscript. Oops, let me move that out of the way. Put that over here. Okay? So the 2 tells us that there are 2 atoms of hydrogen, okay? It's called a subscript, which means we write it smaller and lower than the letters. So see how I've written it sort of down a little bit? Okay, it's called a subscript, okay? And that number always goes with the element that's right before it, not the element that's after it. Okay, so the 2 applies in this case to the hydrogen, and it tells us that there are 2 atoms of hydrogen in that molecule. When no number is written, it is assumed that there is a 1. So if you want to write a 1 in, you can, but you don't have to. Therefore, the H2O means that there are 2 atoms of hydrogen and 1 atom of oxygen in the molecule. The law of definite proportions is one law, and it tells us that every pure substance has to have a fixed and definite composition. So the example that I gave you, again, if we look back at water, according to the chemical formula H2O, water must always, 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 always have 2 atoms of hydrogen and 1 atom of oxygen. If we change it, and let's say I add in an extra atom of oxygen, so now I have H2O2, this is no longer water. It's a completely different molecule. Okay, it's actually hydrogen peroxide, and if you were to drink it, that would really not be good for you. So just by adding an extra atom of oxygen, now I've got something that's potentially toxic for you to ingest. Okay, so the law of definite proportions tells us that every compound has an exact number of atoms. Some important rules for understanding these chemical formula. The chemical symbol represents one atom of an element. So if we look at Mg, Mg means there's one atom of magnesium. Rule number 2. A subscript, so that little number behind the chemical symbol, tells you the number of atoms of that element. So H2 means that there are 2 atoms of hydrogen in the molecule. All right, rule number 3. A subscript outside of a bracket tells you to multiply all the elements inside the bracket. So Mg3PO4 in brackets with a little 2 means you have 3 atoms of magnesium, because again, this 3 goes with the element before it. Now we have some phosphorus and some oxygen, okay, but we also have a 2. So the 2 actually applies to everything inside of the bracket. So it applies to the phosphate and it applies to the oxygen. So when I do that, I actually end up with 2 atoms of phosphorus, because 2 times 1 is 2, and 8 atoms of oxygen. 2 times 4 is 8. So whenever you see a subscript outside of a bracket, you have to multiply all of the elements that are inside the bracket, but not the element that's before the bracket. So notice I didn't multiply 2 times my 3 atoms of magnesium, because magnesium is not inside the bracket. Rule number 4. A coefficient in front of a symbol tells you the number of atoms of that element. So if I write 3C, it means I have 3 atoms of carbon. A coefficient in front of a symbol of a chemical formula tells you the number of molecules of that compound. A coefficient multiplies the number of atoms of each element in the formula. So if I have 3H2O, that means I have 3 molecules of H2O. 3 molecules of water. So if I actually draw those out, here's 1 H2O, here's 2 H2Os, here's 3 H2Os. I've got 3 molecules of water. If I count, how many hydrogens do I have? 1, 2, 3, 4, 5, 6. So I've taken this 3 and I've multiplied it by 2. How many oxygens do I have? 1, 2, 3 oxygens. So I've taken that 3 and multiplied it by 1 oxygen. So if you look at it like that, 3 molecules of water gives you 6 atoms total of hydrogen and 3 atoms total of oxygen. Okay, here are 2 examples. What I'd like you guys to do is pause the video, try these on your own, tell me how many of each element there are, and then play the video back and check your answers. So we're going to do these right now. If you want to pause the video, and I'll go through the answers right now. So 2CuSO4 means that you've got 2 molecules of CuSO4. So the name for that is copper 2 sulfate. You don't need to know that. If you wrote 2 molecules of CuSO4, that's good. So now if I have 2 molecules of CuSO4, that means I have 1 CuSO4 floating around here and another CuSO4 floating around here. So how many total copper atoms do I have? I have 1 here and 1 here. So I have 2 copper atoms, 2 sulfurs, and 4 plus 4, 8 oxygens. So 2 atoms of copper, 2 atoms of sulfur, and 8 atoms of oxygen. All right, let's look at the second one. 2PbNO3. PbNO3, the name for that is called lead nitrate, or lead 2 nitrate. So if I've got 3 molecules of it, it means I've got 3 molecules of lead 2 nitrate. And if this helps, do exactly what I'm doing. So I actually write PbNO3 2, and I write that 3 times because I've said I've got 3 molecules of it. So in this sense, don't be lazy, because this will actually help you to count the atoms if you'd like, okay? Or you can just multiply. So in each one of these molecules, I have 1 lead, 1 lead, 1 lead. So I've got 3 leads total. I've got, because of the 2 outside the bracket, I've got 2 nitrogens, 2 nitrogens, 2 nitrogens, total of 6 nitrogens. And again, because the 2's outside the bracket, I've got 6 oxygens here, 6 oxygens here, and 6 oxygens here. So a total of 18 oxygens. So if I go through my answers, 3 atoms of lead, 6 atoms of nitrogen, and 18 atoms of oxygen. If you can do these really well, that's sort of the hardest that it gets. You have another worksheet, another chart in your notes. We're actually going to do that in class. If you want to try some on your own, you can, but we will have time to finish that up in class. So that's it for today. And if you have any questions, make sure you get them cleared up in class tomorrow.